everybody. Welcome to DevOps Unbound. We have another exciting episode for you here from TechStrong Group. My name is Mitch Ashley. I'm CTO of TechStrong Group and also principal with our analyst firm, TechStrong Research. We have a great panel. You know, this is one of the best things about this job is assembling just some fantastic people, both new and folks that we have known for a while too. Our topic today is we're talking about test quality or quality over quantity. How much testing is appropriate? Do we test less? Do we focus on the right kind of testing? What's the approach we should take? We can automate so much, but are we automating the right things and spending our time where we need to? We've got some experts in the testing field that are on our panel today. So before I do that, I want to thank our sponsors. That's Tricentis, sponsors DevOps Unbound. They've been a sponsor with us for a couple of years now and play an integral role in helping us put together these conversations and think of panelists. So even though the show isn't about their product specifically, they're contributing as a thought leader in the space of DevOps and software testing. And I think is a good example, perfect example of a company who is also contributing back through this kind of leadership opportunity. So DevOps Unbound is a bi-weekly show that we record episodes and appears on techstrong.tv. And we also have live roundtables that we do. So I'm sure and check out our schedule. You can find out on devops.com for the roundtables. So let's jump to our topic. I want to start first by introducing our panel. So I'm just going to pick, I'm going to pick the new person. Kristin has not been on, and I found Kristin's book and I said, this is a person we've got to have on because she seems fantastic looking at her book and what she's done. So Kristin, would you introduce yourself?
Sure thing. Hi, I'm Kristin Jackvony. I am a Principal Engineer 3 for software testing at Paylocity, which is an HR and payroll software company. And as mentioned, I am also the author of the new book, The Complete Software Tester, which is now available on Amazon. It talks about all different aspects of software testing, manual, automated, security testing, performance testing. So if you are interested in those things, definitely check it out.
I would highly recommend checking that out for sure. Congratulations on your book.
Thanks.
It's a labor of love, isn't it?
Oh, yeah.
Next, I'd love to introduce Ixchel. Welcome, and again, returning guest. Tell us a little bit about yourself.
Well, I'm a Java developer, so I'm a Java champion, but I have done all in my career from DevOps, manager, IT. So most of my sessions are about testing, how, when, why, and how to make it the most cost effective.
Excellent. Fantastic. Next, I'd love to introduce another, I say, prolific author. Lee's been with us before and some things. Welcome, Lee.
Thanks, Mitch. It's great to be here. My name's Lee Atchison. I'm an O'Reilly author. My second book with O'Reilly is coming out this week called Overcoming IT Complexity. And I also wrote the book Architecting for Scale. I have a regular article series on Container Journal, weekly for Container Journal. I write for InfoWorld. I write for Digitomica. I do consulting for customers. I spent 8 years with New Relic and 8 years with Amazon and AWS. And so I have a lot of experience in the cloud and the cloud native and application modernization business process. And that's the expertise I bring to my customers.
And the battle scars to show for it, I'm sure.
Yes, definitely.
Shawn, welcome. New guest, Shawn from Tricentis. Tell us about yourself.
Hi, thanks. I'm Shawn Jacques. I've been in software for over 20 years, mostly on the vendor side. I started with IBM and a number of different areas there, and then BMC Software, GitHub for a while, and then into testing with Testum, and they got acquired by Tricentis. So really kind of seeing both the dev and the ops side of things from those different companies and, from different roles like product management and strategy and product marketing. So getting lots of customer interaction and really trying to understand what their pain points are.
Fantastic. How long ago was that acquisition? It was fairly recent, wasn't it?
It was February. So yeah, not too long ago, coming up on a year.
Okay, so under a year. That's always fun, interesting, and congratulations on getting acquired and then you live in the new world, right?
It was a big change for us. A lot of new process that we hadn't had before. So yeah,
you're joining a great company with Tricentis for sure. Well, great. Let's go to our topic here. So, I've been part of software teams my whole life, and the question of how much testing is enough. It's sort of like how much security is enough, right? How much testing is enough? And in my earlier experience, it was the linear waterfall process of all of your time got compressed out of testing and documentation. That you just kind of squeezed in whatever you had time left. And we've really done a great job of kind of rethinking that with DevOps and shifting left and doing a lot of things to automate things. But it's still, I think, a burning question of there's so many kinds of testing to do and how much testing, what's appropriate to automate, because then you got to maintain all that stuff. It's a real challenge. And there's even a school of thought that says, you know what, if we can deliver software fast enough, we might be able to do less testing because we can fix it quicker. Kind of a counterintuitive thought there. So, Lee, I'd like you to start out the conversation and just give us your thoughts on sort of how much is enough and how do you decide?
I'd love to. And of course, like everything else that we do, it all depends on context. And, someone developing a desktop application for in the healthcare industry is going to have a different set of testing requirements as someone's building a SaaS application. But I tend to focus more on the SaaS application world and that sort of environment. And in there, we're really coming to the fruition that the key thing you have to realize is that the cost of a failure is dropping dramatically. The faster you can fix a problem, the lower you can make your cycle time, the less cost a defect has. And the less cost a defect has, the less valuable testing is in general, and the less important it is to the application. And really soon here now, and in some cases, I think we've already hit this, but really soon here, we're going to be coming to the place where the learnings you get from seeing failures outweigh the cost of the failure itself. And once we get to that point, every time something breaks and you fix it right away, you've learned something about what your customers expected that you didn't understand, or about the way the software worked that you didn't understand. You learn something valuable. And once the value of that is high enough, there's actually value in making mistakes. And there's value in learning from those mistakes. So as long as we detect mistakes early, fix them quickly, learn from the mistakes and move on, failure is not bad. Failure is good. And failure actually can be valuable to the building of the application. But all those things have to be true for this to be the case. And that's not obviously the case with all types of applications. But with the online SaaS world of online applications, it's very quickly becoming that.
Interesting perspective, because if your velocity is such that you can react that quickly.
Exactly.
You see your point about you can handle issues. And I definitely agree with the failure is rather than not an option, it'll happen. It's always going to happen. So learn from it. So who'd like to jump in next? Your opinion, counter opinion, whatever you'd like.
No, I loved your answer, Lee. And actually, one of my sessions is failure is not an option; it's a fact. And I agree with you. There are we learn a lot from failure. So there are exploratory tests to see what our customers want. We need that. And when we fail on that kind of test, it's fantastic. But there are others which are more repeatable. So those kind of failures are not adding anything to our development process. So for example, having the test to prevent regression tests still makes sense. Because if it's a project that it's going to be in refactor for whatever reason, you still want to be able to move forward. Even if you're not adding any functionality, you still want to know when you broke things. and the actual impact on your customer of saying, you broke this like 3 months ago and you break it now again. So what are we playing here? So we have to strike a balance for this kind. And the other topic that I want to bring and see the opinion of the panel is developers should test, our quality and assurance team should test. Where do we meet? What is the separation of concerns?
I can definitely jump into that question because, of course, this is an area that I'm very passionate about. So my feeling is the whole team should be testing, and how that gets divided up is really going to depend on the team. It's going to depend on the product. It's going to depend on the underlying architecture. But I definitely think the model of making sure that the developers are writing the unit tests, I think is very important. I think API tests, UI tests, those can be shared by both developers and testers alike. One model that I've seen that has worked really, really well is having the developers put together the testing framework. Like, here's what let's say our API automation solution is going to look like. We've set it up. We've got a couple of sample tests in here, and then the testers can start contributing to that test suite. Same thing for the UI tests. You want to make sure, and I'm a big fan of having way more API tests than you're having UI tests, because UI tests are slow and flaky. They're going to fail. So you want to have as few of those as possible, but you also want to make sure that you're reducing the amount of flakiness by having the developers really contribute their expertise to. This is what a solid testing framework is going to look like. And so then the testers can contribute in a way that's going to write stable tests.
I think that all makes sense. The one thing I just want to go back to is Lee had kind of put out there that, if we learn from our mistakes and we're failing quickly, then we can, we actually benefit a lot from those failures. And the only thing is that there's a big if in there, if we learn. And my dad used to say, if a buzzard had a jukebox on his back, we'd hear music from the skies.
I've not heard that one before.
he tweaked it a little bit. It wasn't on his back, but anyway.
Okay.
I'll just say that what's really important is that we have the data to actually learn from that, and then so we understand why did something fail, and we understand when failures are recurring. There's similar types of failures, or there are failures that are happening for an underlying cause that. Maybe it's not related to the test at all. Maybe it's related to the network connections that we have in my test environment. Maybe it's related to, just the environment setup. And, how do I learn from that information and fix underlying problems and continuously improve?
I still remember earlier in my career, one of my developers saying, well, the user's not supposed to do that. Yes, they are, and they're going to do lots of things.
The world would be so much easier without customers,
if they would only not do that. Well, it's interesting because I kind of feel like we've gone from, and I don't want to be derogatory in any way, but we were so focused on coverage, right? Yeah. Just, do I have everything covered? And this idea of eliminating failure, to trying to be really smart about not only what we're testing, how we're testing it, and how much of it we are testing. Like, for example, we know there's parts of code that rarely get executed. Maybe less of a focus on that as opposed to the things that are, the normative through the track. We always want to make sure that flows as best as possible. Philosophies like that. So I think your point about the data, Shawn, of, it isn't just the test result, pass or fail. It's what does it tell us about, what do we learn from running those tests, right? Even if they passed, right? What do we know from it? I'd love your thoughts on that. Say some more.
Yeah. So like just thinking about, it's patterns are hard to detect a lot of times. And especially when you're just, thinking about, you're not using data to do that. So, we see somebody, in real life, and coincidence become, we apply bigger meaning to it. But when we really think about, data and testing, it's how can we track data over time, and how can we apply, like test results over time to really understand what the trends are. So, one technique is to apply reason codes to failures and to trend those over time, for instance. And so then you start to get patterns. You understand, hey, is it a bug in the app that causes failure? Is it a flaky test that causes failure? Is it a environmental issue or network issue? And you start to follow those patterns, and then you say, hey, because I have so much of my failures are caused by flaky tests, let's spend a bunch of time working on the flaky test issue, or let's spend a bunch of time working on the environmental issue. And then all of a sudden, your passing rates start to increase, and you start to spend less time troubleshooting failures that didn't really add anything to the value of the application.
Yeah, that's a real critical point. I think the worst time you can spend is time debugging problems that had nothing to do with problems with the application itself.
That's right.
Chasing down those rabbit trails that end up not resulting in that. How do you are there some strategies that can help you know you're on the wrong path and not spending your time effectively?
I think it's important to think about just the amount of time you are spending on something versus the amount of reward that you're getting for it. If you've got a lot of UI tests that are running in 3 different browsers or on 4 different devices, and you are constantly seeing failures day after day after day, those tests are not going to provide value because everyone is going to ignore them. If they get a message that says, hey, 20 of your 50 tests failed today, nobody's even going to bother to look at them. And similarly, if you have a test, so here's an example I had, this was years ago, but I was trying to test an email was sent. And so I went through all of this trouble trying to, get into the Gmail application and make sure that the email had been delivered. And that test was so flaky, and I spent so much time on it. Finally, I realized this is not providing me any value. I'd be better off just manually checking this myself. And then a few years later, because apparently the pain of that mistake was not great enough, I tried again. And this time I thought, I'll use the Google API to try and get that email. And the same thing happened. The value of it, because sometimes the email was delayed, when you're dealing with a time delay, you're going to get flakiness. I realized that's too much time. I'm spending too much time on this. This should be just left as a manual check.
Yeah. Go ahead, Lee.
I was going to say, so yeah, I want to insert a phrase here that I think we all are kind of talking about, and that is cycle time, right? In fact, I talk a lot about this in my article that was published last week in Container Journal called Failure is a Secret of Success. But it talks about cycle time and how cycle time has changed in software development over the years. Back in the real olden days with punch cards, and actually I did a few programs in punch cards, so I dated myself there. How long it took you to take a stack of cards, wait physically in line for your time to use the computer, get those read in, run the program, send it back. All that whole process of making a change was so long and so expensive that you didn't dare have any mistakes in that deck, because you lose so much time. And as time has gone on, we moved from that obviously to prepackaged software where the cycle time to fix a defect still could be years. If you send out software to a company like Microsoft Word, right, out to a company in a prepackaged box and then found a bug and fixed it, how do you get that to your customers? It could be a long cycle time before the customer buys an updated copy or gets an updated copy. And little by little, we've been reducing cycle time, where now in many cases, cycle time is a matter of minutes, right? I mean, for web applications, you can deploy a new change, and depending on how fast your pipeline is, you can get a new change up in a matter of minutes. That's a world of difference than what it used to be. And I think talking about cycle time and related to testing makes a lot of sense, because the longer the cycle time, the more valuable testing is to you.
Yeah, I think that's really great. Just one thing to add there is that you mentioned how that there's you had to have those cards perfect. You had to know that they had to be perfect. And, when you don't feel like you have a good gateway on your tests, that you're really going to catch things at the end, then the developers have to be really perfect with their code too, right? And you also, so you can extend your cycle time at the beginning of the development phase if you don't feel comfortable that your tests are actually catching what you want. So, having that good kind of safety net before things release is another way to help give the developers confidence so that they can actually experiment more and not be so worried that they have to have 100% coverage on their code before they release something. So, yeah.
Well, on that regard, I'm Java. I'm coming from the Java world, and I have sit down with the author of Jacoco, and one of the things it's Java code coverage. So that is a tool that we use in the Java world, like de facto tool. There is no project that doesn't run it. And his words is, I regret this, because then teams and companies equaled one number with a goal. And then when we start gaming the system, and then they are starting to become meaningless. So yes, I agree with you. Pursuing these goals at some point, it doesn't matter. On the other hand, even if we spend a lot of time in a test, sometimes we need to decide as a developers, are we going to mock it? Are we going to stop it? Or if it's too complex, maybe this is a reflection of the architecture. Maybe we have to break down this class because it's too big. There are many concerns. So the complexity of the test is reflecting something about our projects, our libraries, or components. So
that's a great point.
Yes. So spending a lot of time on a test can even bring us some perspective on what we're doing.
Yeah, I'd love to expand on that more, because I can reflect back on situations where testing certain scenarios, there's always creating the environment to simulate the test, but just the logic to test certain conditions can be extremely convoluted. And maybe it goes, and I hadn't thought about it at the time. Maybe that is part of the software architecture of the design. Have anybody run into that before?
Something similar. And this is something I talk with my developers. It's like, if you're relying, for example, in throwing exceptions and verifying the functionality as a side effect, see the problem with saying that. You are using a side effect to verify something. So this should already tell you that we have to sit down and rethink this test. So
I think some of the modern application architecture patterns are trying to work towards that too, right? Or the whole idea behind microservice patterns is that you take the complexity out of the software and put it into the interconnection in the system of the components that make up the software, so that you can understand, comprehend, and therefore test an individual component much easier and simpler. And it can be owned by someone and managed and operated by someone relatively simply. It doesn't remove the complexity of the entire application. It moves it outwards, but it does do a lot towards allowing you to build these components, these bricks, these Lego bricks, if you will, to build up the application in an isolated manner and have a higher level of assurance that those bricks themselves are what you expect them to be.
One thing I'd like to jump in on, which is something that Lee mentioned a little bit at the beginning, is thinking about the level of risk involved. And there are some areas of some applications where the risk is just so great that you want to make sure, you don't want to ever have a failure. So I work for an HR and payroll company, and we don't ever want to have someone not get paid because, oops, we released something that, wasn't quite perfect. Or another consideration would be security. Like, we don't ever want to accidentally open up a security hole in an API and not have that immediately detected, because some malicious user is going to take that and try to get information about somebody's bank account or something like that. So we definitely want to make sure that those tests that have the greatest risk, if they were to fail, are the ones that we are making sure to include.
Yeah, that's a great point. That's it is really a risk reward trade-off, right? And because it's, you will have defects in your software, period. Every software has defects. You will have defects, you will have problems. So we can spend our time and energy trying to pound them into oblivion, or we can take a look and say, well, is this important? Is this important? If a problem occurs here that we don't know what it is that going to cause a serious issue or a minor issue? And so those are important discussions, and those are all risk analysis discussions.
Reminds me of Ixchel, your point about failure is not an option. Actually, the saying should be, dying in space isn't an option. Right? Not making payroll. We're going to, they made thousands of mistakes to try to figure out how to get the scrubbers to take the CO2 out of the air, right? So your payroll is we are going to get payroll out. That's got to happen. So you're going to optimize for some things that are extremely important. The risks are much higher if failure happens there. So, by the way, dying in space, I don't think that's going to be pleasant for anybody. So, I'd love to hear you talk some more, Kristin, about. So when you have that clear of a mission, how do you treat certain parts of your testing strategy around that kind of a goal versus other testing that you do across the applications?
Well, at Paylocity, we have all of our application areas are divided up into teams. So one team's strategy is going to look very different from another team's strategy. So, for example, the payroll team, they probably have a lot more API tests, unit tests, and a lot more tests. Even going up the chain into production. And then something else to consider also is just the test itself. You don't want the test to fail in that it accidentally pays somebody who shouldn't be paid. And so sometimes when you're dealing with something like payroll, you have to think about that. And then, we've got other areas of the application that maybe are not as critical, but are, the shiny new parts of the application. For example, we've got a community social application that's part of our product offering. And so we want users to make sure that they're having a really good experience there as well. And there's probably going to be a lot more UI related testing associated with that, because you want to make sure if people are uploading a photo that the photo is going to display and that kind of thing. So you have to consider all of the factors. And then another thing to consider too is when you're talking about continuous deployment, you want to put the most important tests in your CD pipeline, but that doesn't mean you can't test other stuff at other times too. So you can have like a complete suite, that takes 2 hours to run that's running overnight, and isn't causing anybody's build to fail or anything like that. So you can also give that a consideration. Where and when are these tests going to run?
That's a great point. I hear so many companies saying that our test suite takes, 18 hours to run, so we can never do a CI/CD pipeline. No. Let's talk about how we set this up, right? You have that test running continuously. Have it run once a day, on a snapshot, a once-a-day snapshot, and then just anytime a problem comes up, report it back. And that's like a chaos monkey sort of approach, right? You're just having something going off and running and trying to break things continuously and reporting back its results. But what you do for your CI/CD pipeline is more a matter of, is this thing going to be catastrophic or is it going to be okay, right? And that's the sort of test you want to put there. It's a very different set of test suites you want to have for that.
Actually,
that goes to Build Fridays. I just got some chills, but test fails over the weekend, right?
Right.
Sorry, Ixchel, you were jumping in. I jumped on top of that.
Sorry, no, it was my bad. But even that, if they start failing your CI/CD pipeline, it's a little bit too late for me, because as a developer, you should be even running some set of tests before doing the pull request, before pushing. Because if something fails that is critical at this point, and your test either by the CI/CD or your full suite of tests is going to fail in 24 hours, the cost of changing context for the developer sometimes is huge. So you're not only doing a bad service by not running some tests, but you're also paying an overhead time as a developer by not doing it. So having different types of tests run at the server, at the developer's environment, then at the CI/CD. And as Kristin said, maybe you have more complex during the weekends, maybe once a month, maybe during the nights. That having that strategies, it's for me, it's basic.
Shawn, I know Tricentis is a very comprehensive and a test from a test tool company. I'd love to get your perspective on this too, because now we can create environments on developers' laptops that do a pretty darn good job of simulating some of the environment or a lot of the environment, that can develop on the plane and, essentially run a good portion of the tests. How do you look at the whole DevOps pipeline and what testing to do where?
Yeah, no, it's a good question. I mean, we advocate for the pyramid, the testing pyramid kind of approach, but I'll just say that there's, when you think about like the Git process, right? You're going to create your tests, you're going to create them into a branch, you're going to create those tests create those your code in your branch, and you commit it back. And when you commit it back, you should be running tests on your commits, and then think about when that pull request is merging it back in, then you run tests on those. And then when you have a release candidate, you run bigger suites of tests. So it kind of just builds on each other at each level, some with just unit tests, some with integration tests, some with the more extensive UI tests. All can be triggered from the CI/CD pipeline, and that's the way. I mean, 2/3 of our testing customers are running their UI tests in their CI/CD. So I think it's all kind of relates together. If I was to just kind of tie back to that earlier conversation we're having a little bit more about the risk-based testing and how I think it's super important. I mean, you can't test everything, or you shouldn't test everything, and so the tough part is you can identify. Where Kristin says, yes, payroll is really important. We want everybody to be paid. It's how does other companies identify the right spot where I have to spend more time, right? And if we can use some sort of usage-based analytics to understand where the usage is, or to understand where the most likely failures are or the biggest impact of that, something that helps us with data to better identify where we should be spending our time on testing. I think that would be kind of the holy grail, if you will, of helping us to narrow down what we need to test and when we need to test it, rather than just kind of relying on people's intuition, which happens, I think, a lot in a lot of companies.
Yeah, I totally agree. You definitely want to think about who is using your application and what are they doing. I was earlier in my career at Paylocity, I was very surprised, just because I didn't know I was in a different department. I didn't realize that we have millions of people clocking in and clocking out to their shifts every day using our mobile application. And when I found that out, I thought, my gosh, we need to start spending some more time testing clocking in and clocking out, making sure that nobody's going to encounter any bugs. And right now we are actually rewriting our mobile application. And so that's where I'm spending most of my time in terms of planning and strategy for testing, is we've got to make sure that the bulk of our users who use this product are going to be able to use it correctly with no failures of, I can't punch into my shift.
What it makes me think of too, Kristin, is that there's data and then there's data that's important, right? So not to minimize people's vacation time, that's important, but getting their paycheck right is even more important, right? Yeah, we can fix the vacation days if it's wrong, much easier, but it's a lot harder if somebody just can't pay their mortgage because we didn't get the payment amount right or the timing was wrong, right? So your point about the user experience and the UI testing and people entering that data, when you think about, it's not just testing the app, it's also making sure we're getting good data and the right experience, the best experience, people to get that data, whether it's uploading an Excel file or filling out a mobile app or a web page, right?
So one of the things we did at Amazon that I talk about in my book, and it's one of the things I teach my customers, is the idea of service tiers. The idea is any given piece of software, whether it's a microservice or a small application, whatever it is, you assign a service tier, which is a level of importance of that. How critical is the service to the overall application? In the case of like a e-commerce company like Amazon, the cart checkout process was incredibly important because it impacted the bottom line and impacted customers' ability to buy things. But the service that displays a little icon in the corner to tell you the sale of the day is important, but not that important. And the one that shows, the message of the day for a new customer walking in saying today's specials are so and so, that's even less important. And the weekly report to management generation service is probably not important hardly at all, or arguably is negative important. But that's another point. The point is you prioritize and you assign a physical label, a categorization to each service that determines how important that is. And then you use that information. You use it to determine SLAs. You use it to determine staffing levels. You use it to determine interaction between services. If you have a high priority service that's talking to a low priority service, you better be sure that this high priority service will continue to function even if that low priority service is failing. But the opposite may not be the case. If you have a low priority service that's depending on a high priority service, well, who cares if it goes down if the high priority service is also down, because the high priority service is down. That's what's critical. So you can put processes and systems into place that take this risk and the importance into play and treat things differently and put your resources, your risk determination determines where you put your resources and make that work. And that's something that I've seen used in other companies as well too. It's a very valuable tool to be able to keep a system, not just a piece of code, but a system operating.
I just you mentioned the Amazon, and just reminded me, just yesterday I was trying to make a payment, a medical payment, and I realized the company, their business is medical and that's their critical stuff, but by the same token, they want to get paid. And I'm trying to make a payment on my phone, and I enter my credit card information, and I can't press the save button to save my credit card. There's no save button. Doesn't work. I try it 3 times. It keeps deleting everything. I'm getting frustrated. I'm just trying to give them money and I can't give them money. Right. So I end up having to go to my computer and do it. And fortunately, there was the save button. But it's like, if it wasn't the healthcare that I was obligated to, then, I could have gone to another service and I could have bought it from somewhere else. Right. But it's just like, you got to focus on the things that are critical to your business.
Exactly.
Shawn, you don't want to get me started on medical software. I've had a bad week with that this week. Okay?
I'm not sure where you're going, but it sounds interesting. One of the break testing is something that's come up a lot with observability-driven design, thinking about how do you build in more telemetry into your application and your architecture. So it's not just testing it under the most favorable conditions, right? That things are going to work. What happens when things go to heck in a handbasket, right? It's that break testing, I think, is almost more important than when conditions are right. So, and what kind of break testing do you do? Go ahead, Ixchel.
Yes, I mean, it is interesting that sometimes we have this idea of how our users are going to use our application, and we set up our tests in a pristine, in laboratory kind of ways. And actually, we have the best computers. We are super close to our data centers. Everything runs fantastic. And turns out that our users are in the middle of Africa, and they probably don't have even a smartphones, nor have good network. So the fact that we have this rich, amazing tests, they are passing, is irrelevant. The other thing is that it doesn't matter how much test integration, A2I, contract, you need, end-to-end, whatever we are defining here. They are all bound by our imagination. We are defining the tests. They live in our heads before they live in the code. So, and we're flawed as humans. So we also have this issue of very short-sighted and very limited imagination. So that's why we start thinking about chaos testing. Like, let's do something unimaginable, or like we haven't imagined. Or let's do this, like, what happens if I pull the plug on this? Are we going to, and then the test should not only help us to say you're up or you're down, or this is not working as expected, but also give us an idea of this test, like if we are failing graciously, because as we all agree, we're going to fail. Like, we are going to fail. At some point, something is going to be down. Are we reacting the right way? So this kind of very dramatic tests where we kill randomly things help us not only to verify that our flow is as we expect, but also how do we react?
The chaos monkey style of testing, I completely agree. It's something I emphasize a lot. Is you're absolutely right. Is what matters is the customer's operational environment. And that operational environment is where they're experiencing the software. And you probably don't know what that is. No matter what industry you're in, where your software is, it doesn't matter. You don't know what the customer's operating environment is. And, whether it's, their cell phone on a 5G network that's probably pretty good, but maybe not perfect, or if it's someone in a third world country that has an internet connection for a couple of minutes and then it goes away, or whatever the issues they run into is, or imagine chaos testing in a country like the Ukraine right now, where infrastructure comes and goes and disappears, what that means to software infrastructure. It's the operational environment of the customer is really critical, and a lot fewer pieces of software than should take that into account. Did I say that?
Coming up close to the end of our time here. Let's do this. Shawn, you want to kind of wrap up for us? I'd love to get your thoughts on the sort of break testing and the environmental factors of how do we handle failure and handling it gracefully.
I'll just say that, and maybe I'm not directly answering your question here, but the one thing that I've noticed is that there's a lot of testers who have developed it kind of as an art. They believe that they really do a great job of putting their mind in the user's perspective, and they think about the way somebody would use the software. But again, it's an art, and I think it takes a lot more skill, and we need to come up with ways in our software and in the processes that we're using around our testing, so that we're not relying on individuals to be especially thoughtful in their testing, that we can give them guidance that helps them understand where they need to think about testing. So so that they are thinking not just about the happy paths, but the negative paths and the things that can happen if everything's not going the way it should go. And so it really comes down to like, how do we help those people and those teams, broaden their thinking and approach testing from a more analytical perspective, as well as the art side of it.
Fantastic. Thank you, Shawn. Well, let's wrap up with this. Kristin, tell us the name of your book again, where people can find it.
Yes, it is called The Complete Software Tester, and it is available on Amazon, both as a paperback edition and a Kindle edition.
Okay. And Lee, your new book?
Overcoming IT Complexity, available on Amazon. It's on Kindle and paperback, and it will be available sometime next year in an audio version as well.
There you go. You can listen while you're driving or flying on that airplane. Yay. All right. Well, thank you to our great panelists today. And thank you for everybody tuning in to our episode on testing. How much testing is enough? Quality versus quantity. It's been a great conversation. Thank you to our newest panelists and also our returning panelists. And of course, a big thank you, shout out to the Tricentis team. We love working with you, putting this together, and thank you for sponsoring the show. So be sure and check out another episode, either upcoming on TechStrong TV, if you can find it on the homepage of techstrong.tv and also in the menu of video shows, as well as check out DevOps.com for upcoming roundtables that we're having on various topics around DevOps. So appreciate you all joining us, and tune in again soon. We'll see you all.